Hello friends, today we are going to discuss about rolling motion. So this is a very important topic of rotational motion. And so what is rolling motion? An object which is rolling that has two components. One is translational motion, other one is rotational motion. Let's see what is translational motion. This round object rather, will be just moving on a straight line. So it is moving with a linear velocity v, and the center moves with a linear velocity v. So also the top of the object, that will also move with a linear velocity v, and also the bottom of the object will also move with a linear velocity v. Okay, now let's see the rotational motion. That is, this object is rotating along an axis that is passing through the center with an angular velocity omega, and let's assume that the radius is r. Now, due to its rotation about its axis, the linear velocity of this point is omega into r, since the sense of rotation is clockwise. So this will be on the right hand side, and at this point I can assume that it is on the left side, omega into r. Now, if we can add the translational and the rotational motion, it will combine to give, this will be rotating with an omega, with an angular velocity omega, and the center will still move with a velocity v, a linear velocity, and the topmost point we can see here the velocity is v, and here the linear velocity is omega r in the same direction. So we can add them, omega r plus v, and here also the velocity is v, but the angular velocity, the linear velocity due to rotation, that is omega r, that is in the opposite direction. So it will be v minus omega r. Now, for pure rolling, the lowermost point which is touching the ground, let's say point O, this point will have velocity 0. So I can say v minus omega r, that is equal to 0. So v is equal to omega r. So this is the condition for pure rolling of an object.